All right, so that's cool. I can grab these joints and I can move them around, and that lookout joint is staying right in the middle. That's great, but nothing's happening with the actual geometry. So let's start to figure that out. And the way that we're going to do this is I'm basically going to say, all right, the first thing that we need to do is we need to make sure that the mesh is actually orienting itself such that if I drag this guy up here, as I was drawing in my gross little graph earlier, is it stretches up here and points down to the direction and down at the lookout joint. First thing I'm going to do is I'm going to establish the lookout matrix for our deform object itself first. Okay. And so what that means is I'm going to create a new variable here, and I'm going to build up a transform. Now this you're going to do all the time. And this is the apex.transform.Build node. .build node. Okay. And this is how you build up basically a I want to move a matrix, or I want to rotate, or whatever it is. You say build, and in this particular case, I want it to be the transform. I'm going to build up this vector, and in this particular case, I want to go into the -1 on the z-axis. And I mentioned earlier that the reason for this is that when you establish a lookout, it always follows the -z. So if you want it -z, so if you want to forward, you got to do it by the negative. So this is what this is going to set this up to do. Then I'm going to actually apply that. So I'm going to create. This is going to be basically our look direction, and we're going to multiply this by the center. Okay. Okay, great. So in order to see kind of like what did this do, I'm going to set our debug to lookdir and save. And notice our lookout joint now is moved -1 in the z. Okay. Now this is going to start to get interesting here once I start to apply these matrices to the actual deform node of our object mesh. Okay. So let's do that now. So what that looks like here is, if right now I'm just doing debug, but let's actually create the return type that will actually be the deformation matrix for the parent of the deform node, i.e. the parent in port of our deform node. Okay, so let's do this. And actually, let's just say, to give you an idea of what's going on here, if I take the squash node dot debug out and connect that right now to the deform node dot parent in, see that? The entire object just jumped to where that lookout joint is, that matrix that we were just debugging. Okay. So that's the way you can kind of see how once we start to manipulate this matrix, and this is what we're ultimately doing, that you can start to see that in real time. So I'll just comment that out for a second and return. Okay.